so you're going. Could care less about the five you're blowing. Theater gets dark just to start the show. Then you spot a fine woman sitting in your row. She's dressed in yellow. She says hello. Come sit next to me, you fine fellow. You run over there without a second to lose. And what comes next? Hey, bust a move. Just bust a move.
Alright, here we go. My favorite song, I used to think it said Bust a Move. Turns out it's really Bust a Move, Young MC. Fantastic song. Here we go. Let's get more into graphing. Now we're going to start graphing some lines. This is 5.2. We are graphing using intercepts. So let's jot these down on your notes here. If the title of the section is called Graphing Using Intercepts, we better know what an intercept is. So let's go ahead and define these things. We've got an X-intercept and a Y-intercept. If you need to pause to write that down, please write that down. We're looking at the point at which the line crosses an x-axis or where it crosses the y-axis. So these are X and Y intercepts. Excellent. Now what does that mean? So once you have that jotted down, what does that mean? So we're going to start graphing lines using these intercepts, using where it crosses the X and Y axis. So again, we're good with this is the X-axis, this is the Y-axis. Now we're talking about something different. Now we're talking about intercepts. So these are the axis, but now we're talking intercept. So what is the X-intercept? The X-intercept is where it crosses the X-axis. So the line is crossing right here at 2. So how do I name that point? Remember, points go X comma Y. You're saying I go over X, up Y from last section. So this point right here is over 2, up 0. So that is the X-intercept is right here. What about the Y-intercept? Same idea. It's crossing right down here at -3. So what am I going in the X direction if I name this point? I'm going 0. And I'm going down 3, so I'm at -3. So X, when you write these intercepts, they're going to have a 0 in it. Either the Y is 0 or the X is 0. That's really the whole idea. X-intercept, what is X when Y is 0? Y-intercept, what is Y when X is 0? So then once we have them, we can graph them. Awesome. Can I look at this picture over here? Sure. Where's the X-intercept? Ooh, we got decimal. Is that okay? I'm just going to have to estimate the best I can. It looks like what? It looks like it's over -1.5, 1.5. And the Y value is 0. Then if I go, where does the Y-axis cross? Well, when X is 0, it looks like Y is -3. Fantastic. Very nice. How about this one over here? Where's the X-intercept? Where does it cross the X-axis here? Aha, it doesn't. It's a trick. There is none. So it doesn't always have to have one. So in this case, there is no X-intercept. Is there a Y-intercept? Sure. Here's where it's crossing the Y-axis. Up there at 4. So it's over 0, up 4. There's your Y-intercept. Fantastic. Alright, here we go. So, the other thing we need to know about this, I'm going to move the y-axis down here, alright, is what type of lines are these? Are these positive lines, negative lines? What's going on here? So when I think about these things, I always think about the little yodeler, the little mountain climber from Price is Right. Before Drew Carey, back old school Bob Barker, they used to have this guy and he'd yodel, and for every dollar you were off on the price you guessed, he had to climb the mountain. If you climbed too far, he fell off the end. That's what I think of. Think of somebody hiking. Is this line, when I look at this like reading a book left to right, is this line going up or down? Is this a positive or negative line? Some people can look at it real quickly and say, oh, it's positive, it's going uphill. Think about a climber. If he was going to climb this, what's going to happen? He's going to come, I'm going to have to rotate him a little bit so it hits it. He is going up this hill right here. So this guy is going, he is going, woo, and he yodels when he does it. He is climbing uphill. So that is definitely an uphill climb. So if it's an uphill climb, what does that mean? Well, this line for sure is positive then. So this is a positive line. So think of it left to right like reading a book. What about over here though? What about the next one? Some people are pretty good at just looking at it. How to describe this line? It's going down. It's going downhill. Or think about if he had to climb this, what would happen? Well, we'd have to change his whole incline, wouldn't we? This is a negative line. So here he goes from left to right, and he yodels. Much different than that, But he's going downhill. So if he's going downhill, what's happening? That is a negative line. Fantastic. And then the last one. This is kind of a special case, but this will happen. What's going on here is he's got to, I got to straighten him out a little bit here. Think of this climber. This would be the perfect hill for him because why? It's flat, isn't it? Check this out. He's left to right. He's going straight. He's going flat. He's not going up or down. So what do we say? It's not positive. It's not negative. We say the slope of this is 0, or this has a 0 rise to it. It's not going up or down, it's just 0, it's constant, it's flat. Fantastic. Let's check out the next one. Thank you so much.
On the next one. Now I want to graph some points here. So let's graph some lines here. I'm going to graph them by using the intercept. So it tells me the x-intercept is -5. So I'm going to put a dot here where it crosses. It tells me the y-intercept is +5. I'm going to put a line there where it crosses. And I'm going to come over here and graph this line. So I know this is going to go through here. This is going to go through here. I'm going to kind of extend them a little bit. Boom, there it is. So there's a nice line right there, and this would be a positive line. Looks like a very nice positive line. Excellent. Try the next one here. Pause it. There's one here, and then there's one under the screen. And when you're done, we'll check them out if you got them. So here we go. This looks like x is 2. The x-intercept is 2. The y-intercept is -3. So I've got these 2 points right here. Let's go ahead and grab a line. And I'm going to say this line does something like this. Oh, I nailed it almost the first try, didn't I? Woo! Look at that. Perfect. Perfect. So it's kind of going through those 2 points. And again, another positive line. Fantastic. How about this one here at the bottom? It says the x-intercept is 4, so we'll go to 4 and put a dot. There is no y-intercept, so what are we going to do here? Well, it's got to be parallel to the y-axis. It can never touch it. So it has to look just like it. So wow, we've graphed a nice vertical line. So we didn't have this on the first one. We had positive, negative. We actually call this undefined. And we'll talk more about why that is next section. But this is an undefined line. So we have positive, negative, 0, and undefined. So we're going to see these in every section, these different type of lines. Fantastic. All right, so now we're going to graph lines. So we use the x and y intercept. We're going to use an equation now to help us graph lines. So this is called the standard form. We're going to learn another equation later on. But this is standard form where you say ax plus by equals c. Now a, b, and c are just constants. They're just numbers. They're like the coefficient of x, the coefficient of y. These are just numbers. So like, for example, let's take a look at this. If I wanted to graph this equation, this is the equation of a line. Slow moving there. Come on, you got it. You can do it. All right, there we go. So if I want to graph this equation right here, this line right here, it's like saying, here's my A. A is 2, B is 3, and C is 6. These are the coefficients here, and they'll be very important later on in the year for labeling those. But this is the equation. These are just the numbers in front. 2x plus 3y equals 6. So I can graph that. And really what I got to think about is here, I'm going to get rid of this real quick. Let's see, delete that. Alright, so what I want to do is I got to think about, like, let's say I want to find the x-intercept from this. Well, when I think x-intercept, what do I think? Well, I think it's some x value when y is 0. So that's how I find the x-intercept. So I'm looking at that. That is the x-intercept. And the same idea goes for the y-intercept. If I want to find the y-intercept, I'm looking for some number y when x is 0. So that's how I find the y-intercept. So if I do this first one right here, let's do it for the x-intercept. I want to find the x-intercept, so I don't know it. So I'm going to say it's 2x plus, what is y? Well, y is 0. So I'm saying when y is 0, what is x? So when I'm doing that, I can say, oh yeah, 2x plus 3 times 0. Well, 0 times anything is 0, so this is just gone. So I'm saying really 2x equals 6. And then I can divide both sides by 2 from solving equations and say x is 3. So I know this x-intercept is 3. All right. Did I have to show all those steps? Well, I usually like showing a lot of steps, but really I can use this what's called the cover-up method. If I know y is 0, I can just cover it up because 0 times anything is 0. So I can cover up this 3y and just solve this equation. I could have just said, what is 2x? When 2x equals 6, I could have just directly said 2x equals 6. Cover up the y value because it doesn't matter because y is 0. So 2x equals 6, divide both sides by 2 just like I did. There's my x equals 3. Awesome. So I know my x-intercept, that was right, is 3. If I want to do it the other way, remember you're saying x is 0, so I'm going to cover it up. 0 times anything is 0, and now I'm going to solve this equation. So down here somewhere I'm going to say, really I'm looking at, when does 3y equals 6? Well, 3y equals 6, divide both sides by 3. It's when y is 2. So there's my y-intercept. It's at 2. Put it right there at y is 2. Now I can go ahead and draw the straight line through those. Oops, I hope you hit better than I did. on the X and Y intercepts, and I've got it. Fantastic. Let's try it for another one here. If I look at this line, 4x minus 3y equals negative 12. So again, let's find the X-intercept. I'm just going to go ahead and cover up this y, because I know y is 0. So cover all that up. I don't care. Use your thumb, whatever you got. I'm going to say y is 0 because I'm looking for the X-intercept. So I'm going to say 4x equals negative 12. And then I'm just going to solve this. What does x got to be? Maybe you can do in your head, but I'm going to go ahead and show the steps. Divide both sides by 4. I'm looking at negative 12 divided by 4, which is negative 3. So I know my X-intercept is here at negative 3. Let's go again on the y. So I'm going to cover up my x's. X is 0. So I want to know what is y when x is 0. So really be careful because this negative comes with it. This is all one term here. It's minus 3y, which is the same as negative 3y, equals negative 12. Now solve this bad boy. I'm going to say divide both sides by negative 3. So really I'm looking at when y is what? Negative 12 divided by negative 3 is not negative 4. You got to say a negative divided by a negative is what? It's a positive. So a negative divided by a negative happens at 4. So really I'm going to say this happens up here at 4. Got the y-intercept, got the x and y-intercept. Go ahead and draw a line through there. And we've got our line graph from the original equation. So the
Alright, now that you've kind of seen how to do it, go ahead and pause it, try these two, see how it goes here. We've got two problems. Go ahead and find the x and y intercept, graph it, and the one on the left even has a little point for you to find. So try it. I'm going to write the answers up. Good luck. Alright, so here are the answers. Whoa, my screen got a little bit off. How about this? Here are the answers here. Check them out. I got the x-intercept at 3, the y-intercept at 4, or 3.75. So I took this fraction, made a decimal, and then put on there best I could. Is this point a solution? Yes. Replace your x and the y, plug them in. 15 equals 15. So yes, that would be on the line. Negative 5, positive 10. It's not on my graph, but if you continue, it would be on there. Coming over here to the right to find the x-intercepts, or find the intercepts. There's only an x-intercept at negative 6. There is no y. There's no y in the problem, so there's no y-intercept. So we got one of these weird vertical lines that's undefined. Excellent.
Why would you ever want to do this? Well, let's look at a problem. Let's check out a nice application problem. So I've got a Facebook problem here. Basically, this is a graph showing my friends on Facebook. I got the logo here. I've got this graph. So what is the y-intercept? Well, let's find it right here. Here's the y-axis. So I'm only looking at the first quadrant. So it's still x and y. Here's the origin. Here's 0, 0. But now check this out. I cut off this whole negative. This would be the negative direction. Why? Well, I don't need negative time. I don't need negative friends, hopefully. I hopefully don't owe anybody friends or else I'm in trouble. So I'm only looking at the positive. So I'm only looking at this first quadrant. So a lot of real-life applications, we use that first quadrant. So if it freaks you out, you can draw it in here if you like. Let's check it out. So here's my y-intercept. I found it. Boom, there it is. Y-intercept. It looks like it is at what? It's at 95. And technically, I really should be writing the whole coordinate. What is the coordinate of this? It's, well, if I go 0, comma, 95. That would be perfect. I go over 0, up 95. That's my y-intercept. What does it mean? Well, I don't know. What does it mean in this problem? It means that x is what? Time and days. So at day 0, how many friends do I have? So I start with 95 friends. So I'm pretty cool, I would say, virtually. Start with 95 friends. I don't know if you have 95 friends on Facebook. I think I have more Mr. Kelly on Facebook, I would imagine. Probably Mr. Sullivan, if I don't combine to that. Maybe you have more than that. That's okay. I got my 95 friends. Then I'm going to look at my x-intercept. Well, let me change colors so I got too much red going on. Down here, well, here's where it's crossing the x-axis. So I can see, well, my x-intercept's 19. And really, let's go ahead and make this a coordinate. I'm over 19. And I am up or down 0. So really, it's 19, 0. Well, what does this mean in this problem? Well, it looks like on day 19, wait a minute. Day 19, what's happening? Oh my gosh, it means that I have no friends. Now you may want to write Mr. Brust has no friends instead of I. People look at you, write notes, and say you have no friends. Let's change that. Mr. B has no friends. Mr. B has no friends on 19 days. How is that possible? Wow. I don't know. We'll have to check that out here. Can we talk about rate of change? How fast am I losing friends here? Essentially, I'm losing friends. How fast do I lose them? Start with 95. I go all the way down to 0 in 19 days. So I could say I am actually losing 95 friends. How often? I lose 95 friends every 19 days. And maybe this reduces. Maybe not. I think it does, though, doesn't it? If I check out this graph and make it a little bit closer, in just one day, how much did I lose? It looked like I lost how much? Ah, it does reduce. You can say that I lose negative 5 friends per day. So I'm losing 5 friends a day. Per day. Wow. Not a very good rate of change. I don't know. You guys mind if I check my Facebook real quick? Let me log on there. Oh, sorry. I'm logging in. Internet's a little slow. Ah, there it is. Let me check my account real quick. Look at my highlight a few things and see why am I losing friends. Not sure why. My mom wrote, oh, yeah. And, oh, here it is. I posted on Mr. Sullivan, and I don't know if you know Mr. Kelly. Yeah, you guys know Mr. Kelly. He is actually Timmy Cat on a screen name. I put, do you guys like math? What did Mr. Sullivan write? Please stop posting on my wall. Wow. All right, Mr. Sullivan, thanks. Timmy Cat said, agreed, I'm going to block you as a friend. Awkward. That's a little embarrassing. Maybe that's why I'm losing friends. Unbelievable. I can't believe it. Unreal. So that could be part of the reason why I'm losing friends on Facebook. I had to find some other math teachers to hang out with. So
what do you bid on that prize?
$100, Bob? No, between 20 million and 20,000.
The mountain climber is going to move one step for every dollar you miss the prize.
Wait a minute. Say what? No, stop, please. Okay, I guess I was wrong.